Quit. Right down. Right down. No.
No, we had a lab. I had to put on
I'm sorry.
goggles.
I'm sorry.
What does he say?
It hurt. Like, it hurt so bad. Oh my god.
I don't know where that went.
Why it's low? Does it look bad?
Don't.
No, but I go from a net not long ago, and I apparently have mine.
Dude, every day when I sleep at English, I wake
Stop.
up and I used to sleep like this. This is what I wake up like. It looks like I did like a big red hot.
How did little
Either one of the Palmers make it. Leave it out there. Leave it.
It looks like you're wearing a goggle.
Yeah, that's you.
I didn't know what you were talking about. Okay. It does.
Alright, here's what we're starting with. E, the number E, that's an approximately, be quiet. Approximately is your squiggly equal sign. The number E is approximately 2.7, and I'm going to give you a lot of digits on this. 1828. 1828. 46. Okay. Now, I said approximately on there because E is like pi.
Yeah,
It keeps
that's what I
going.
was gonna say.
It keeps going. Put your chair down. It keeps going forever. Okay. It's just like we think of pi a lot of times as 3.14, but it really keeps on going forever. It's irrational. E is irrational also. Okay. There's E comes into play when we get into logarithms next week. When we start using logarithms. And there's a little stuff here I'll read you about E real fast. It says the history of mathematics is marked by the discovery of special numbers such as pi and I. Another special number is E. It's called the natural base E because Euler, E-U-L-E-R, was who discovered it. Okay. All right, and it has to do, we're talking about exponentials. It actually comes from this expression, 1 plus 1 over x to the x. Euler, whatever his name is, did some work with that expression somehow. I don't know how. I wasn't there. I don't ask questions. And came up with the number E. It's like pi. We use it when we're told to, and that's it. I don't know about any of the proofs of it, how it came, what he did with that. I don't know. I've not studied that. All right. Easy stuff for us to use in class here. Looking at e to the third times e to the sixth. Here's what our directions say. Simplify the expression. Okay. All we're doing on this is using our power rule. Let's multiply with same base. What do you do with powers? Add them. So this is the same as e to the ninth. And that's it. So it's that easy, even though y'all are like, oh great, the number e, I have no idea what it's talking about. You can still work problems and use it. You don't have to know how it proof and all that kind of stuff. Alright, so this one we've got says 16e to the fifth over 4e to the fourth. What would this simplify to?
4E.
16 divided by 4 is 4. Take your e's, 5 on division, you subtract. 5 minus 4 is 1, so 4e to the first. You can write that as just 4e. Nothing to it, nothing to it.
So this is all...
Well, we're going to do a little bit more, but it's still pretty basic stuff. Yesterday was pretty easy. All this basic stuff we're leading up to is for solving logs that we're going to get into next week, which I know you don't even know what a log is yet. It'll be fun
Is that
times.
like tangent, cotangent?
No.
When do we get to that?
Second semester. Let's read what that says. Negative 4x. Alright, so that says 3e to the negative 4x squared. Alright, what we got to do with that squared?
You have to put it on everything.
Everything meaning the 3 as well. A lot of people will forget that, but Landon's reminding us that we also have to do 3 squared there, right? So that would be 9. Now when I take it to this piece, what do I do there? When it's power to a power, when I've got a second and a negative 4x. You do multiply them. Very good. Okay. Now that's simplified pretty good. I like that pretty good. But the dilemma is we're told we can't leave negative powers. What happens when we had a negative power? Did it last unit.
Over 1.
Very good. Goes on bottom and becomes positive. The 9 doesn't have a negative power, so it's going to stay on top. And then e to the 8x power is on bottom. So that'd be your final answer. Hey, hey, hey.
What is ho, ho, ho?
It is beginning to get close to Christmas.
What are you getting for Christmas?
Nothing.
Hopefully a new house.
I hope, but I don't think I'm going to be moved in it yet. He said it'd be January yesterday when I asked him. Our original completion date was November. Now we're back to January.
You already have stuff in it?
Mm-mm.
Is all your stuff at your house packed up there?
Not really. Not really. I mean, like, furniture-wise, I'm getting new furniture. Appliances are being delivered December 22nd, so they'll be there then.
You're getting new appliances too?
Clothes and stuff like that. I mean, like, literally, the house I live in now to where my new house is as far as for me to gate. So I'm just going to, like, walk and carry stuff. Maybe, like, put it in a wheelbarrow or something. Be fun times. Maybe I can pay my nieces to come carry stuff.
Oh, yeah, sure.
They won't do it. That's work. I try to, like, let's go rake Memes' yard. No, that's work. Lazy little turds. All they do is play video games.
Girls?
Yeah.
Girls can do anything guys can do.
Yeah, that's great.
What?
All right, look at this. Y equals 3e to the x. Directions on this say to tell whether it's an exponential growth or decay, because these still are exponentials. So this is the same stuff that we did yesterday. Tell whether it's a growth or a decay, and then we're going to graph it. Okay? Dalton is right.
How you put E in the calculator?
I'm going to show you. Dalton is right. It is a growth because our exponent is on E, and E is 2.1 something, so that's bigger than 1, right? So that is a growth. All right, now to do this in your calculator, because this is how you would have to graph an E. It's not like you got a lot of...
Log? Is it log?
No, it's not a log. It's E. Just simmer down.
Simmer down, boy.
Let me get my ladybug cracking here. I haven't had it on yet today. I actually got an updated version of Ladybug when we updated the computer stuff. Did not know it's working.
I know how to do it.
Do you? Good job.
Yep, look.
No, that's not it, bud.
Yep, that's it. I got it, sir.
Just see anywhere. Oh, there's a plus sign. Zoom. It's not letting me zoom. Alright, so in our y equals, I wonder why it won't let me zoom.
Y equals.
I made it a little bit bigger. Our y equals, now I've already forgotten what the equation was. What was it? Y equals what?
3e to the x.
So we got our 3. Now to get our e, there's a couple of different places in there where your e is. Go down to your left side and we'll see on the LN button.
Yeah.
Right above that in blue, so you're going to hit second.
Oh, boo.
E, and it already boxed that up there to the exponent spot for you. So then I'm going to push my x right there. And then
graph,
just hit graph.
You just hit graph.
It's growing.
Okay. Now, If you needed some points like we did yesterday, we could go look at our table. Look how, get down to some positives there. See, well, there was a whole number 1 on 0 because we know anything to the 0 power is 1, and then we multiplied that by 3 and got 3. But other than that, you're not going to have the whole numbers that you had because you're multiplying by 2.71828, 1828, whatever, right? E is an ugly decimal, so you're going to have ugly decimals. Okay? Everybody all right on that? Everybody can graph an E function?
No, I cannot.
Why not?
This is saying error.
Let's figure this dude out.
He's an
Yeah,
error.
no,
How long
it's
would you think it would take to memorize the entire thing of pi?
You can. It still goes.
It goes up forever.
There's some dude sitting at a computer right now figuring out the next digit of pi.
Like, that's the worst job
That's
in
a
the
sad
world.
person. Reason, and it's a little bit interesting to me. Pi is the ratio, the division of circumference divided by diameter of a circle. So you can just always keep taking it out one more decimal place. It never goes into it evenly.
I bet there's like quite a bit of money if you sit there.
That'll drive me nuts.
53, go straight to your catch. There's graph, there's your graph.
Ah!
I'm still making notes.
Yeah, I don't like
One word. Still have more coming.
Fruit's good, bro. Oh, forgot that.
I'm just gonna let me come back. Then I said, I need to take a picture of
Alright, now this one a little bit different here. I got f of x or y. I'm just going to write y. It could be f of x. Y'all listen, be quiet. Is e to the negative 0.5x. So you're going to graph that, but I also want to know if you think it's going to be a growth or a decay.
It's definitely
It is a decay. Okay, now this one's a little bit different because you're going to say, well, the b is 2.17 and that's bigger than 1. But what you got is a negative up there with your exponent. So remember, a negative exponent puts something on bottom, so that 2.7 actually goes on bottom. So that would be 1 over 2.7. That's how you justify that and make it a decay. 1 over 2.7 whatever to the x power. Type it in on your calculator, though, to graph it just like it is. Okay, type that in just like it is and graph it. And you'll see it go downhill. You'll see it is a decay. Everybody got it graphed? Practice this so you'll be able to do it.
Yeah.
He's messing with me.
Did you get the...
No, he did something. I beat him. And he's mad.
Oh, what did I do?
Kid, quit it.
Yeah.
Yeah, but I'm not writing on your paper.
Why are you so mean?
Me? You ain't trying to write on my paper.
Alright, yesterday we did a compound interest formula. Remember, look in your notes, it was A equals P times 1 plus R over N to the NT power, compound interest. Today we got another bank formula, and it's called continuously. C-O-N-T-I-N-U-O-U, continuously compound interest. It's a little bit different. It's obviously going to involve the E. Okay, it says our amount is equal to the principal times the number E to the RT. Remember, R is rate in decimal and T is time.
What is that last word?
Interest. A equals P times E to the RT power. I always remember that because when I was a little tot, my grandma used Pert shampoo, and that kind of looks like Pert. There was a shampoo brand called Pert, P-E-R-T. I think there still is, I don't know, but when I was a little tot, my grandma used it. Pert. Alright, so what we got here? And you'll have to be told specifically whether or not you're using this formula or not. The problem will specifically say the interest was compounded continuously. If it doesn't use continuously, you won't use this formula. Okay, it'll specifically say continuously in the problem. Alright, so it says you and a friend each have an account that can earn annual interest compounded continuously. See, it said continuously, so you know. The balance A in dollars of your account after 2 years can be modeled by this equation. A equals 4,500, so there's the principal, times E to the 0.04, so interest must have been 4%, T power. Okay, so what we got there is that means my principal that I deposited was $4,500. That's in the P spot. My R, 0.04, that's 4%. So I'm earning 4% interest on it. And then I don't know the T. That's still a T there. Okay, so that's what we're looking at. So far, we already got a P and an R plugged in. Okay, let me go see what it asks for next.
T as in
Time. Oh, sorry. I thought you were talking to me. I'm sorry. I'll shut up. Alright, then we've also, what we're supposed to be doing with this is comparing this to our friends whose is on a graph. But here's what we're going to change this up a little bit. I just want to know what my balance is going to be after 10 years. So what would I do to figure that out?
Times about 10.
No?
Put a 10
Good. 10 in the T. Very good, Crystal and Landon. So I'm going to say A is equal to 4,500 times E to the 0.04 times 10 power. Okay, and you can type all that in your calculator. Remember when you do it, this is money. So if there's decimals involved, money rounds to the nearest hundredth.
Nope, you're wrong.
Let's see how you type that in.
Dude, I
Because
think you did it
Why do
quick
we
touch
look
my
at
calculator.
I did.
That's what I think.
Oh, negative.
It's getting bad.
Oh, why you get all mad and angry over there?
I didn't even touch you or talk to you. You grabbed my
I was
calculator.
trying to see.
Why don't you just type it in yours? It takes like 10 seconds.
Was he wrong?
Alright, that's what Steven's showing on his, $6,713.21. Tell me now if you need help typing this in your calculator.
I think Dalton does because he needs to think about it.
Dalton, you got it, buddy?
Get it, buddy.
You don't.
I think whoever sits in those two seats up there argue the whole class period. Yeah.
It didn't show up on my screen.
Sit down. It's not going to show up on your picture because look, it's got 4,500 in there. Remember your windows.
What are we trying to figure out?
Yeah.
Go to your home screen and you're just calculating. So just on your normal screen, type it in.
Oh.
Now, what you would have done,
He's opening it again.
you
For the
could have
number
got it
nine sound
by graphing by going to your table
Hey, Gary, got pigs.
and looking for where
Cheers,
X was
I'm
10. See,
Huh?
do this. All right, so that's the right answer. See, that's what we got. Now let's go look, since you did it the other way. Go look at your table. Oh, you already cleared it out. Never mind.
If it hits 40, you're busy.
Did you already
I'll show
clear it
it
out?
later.
Yeah, but you could have done it that way. Looked at your table and looked for where X was 10.
Or you need to pay it.
Alright, so when we say we did in math class today, when we say what'd you do today, we did learn the natural base E. Sounds pretty big like you did something major.
So tell people that so they think you did something major.
Well, but we didn't. Okay, so I just don't want you to get overwhelmed. Oh my gosh, we got another letter and it actually equals some number. We did nothing new today except learn where the button E was on our calculator. Okay? So there's nothing difficult. Don't be bogged down by that. We just learned where the letter E was on our calculator. So I'm going to give you a problem, and it's early because that's all there is to this for today. So I'm going to give you an exit question, and I'll get the spot typed in your classroom for you.
Don't ever pick one.
Ever touch hot stuff.
You would so good when I was at school.
She tried touching hot stuff.
No, I didn't.
She put it in her mixer wrap. It's on my face, baby. She could try touching hot stuff.
Same type of question as yesterday. That says
Letter
Y.
Or Z?
That says Y equals E to the negative 2x.
All you gotta do is type it in your calc.
It's even easier than that, but you can't do it that way.
No.
Okay.
Oh, I gotta type the question.